After simple grammar, next category of grammar is quasi-simple grammar. Quasi-simple grammar obeys the restriction of simple grammar, which means they need to follow the rules of simple grammar. And if you still remember, the first restriction is if you have a rule like this, after the derivation arrow, it must start with a terminal. And the second restriction is if you have two rules derived from the same non-terminal. So for example, this is the same non-terminal as the terminal after the derivation arrow must not overlap. As for quasi-simple grammar, it can also contain the third condition, which is it can have rule of this form. After the derivation arrow, it can be derived to epsilon, and this type of rule is called nullable rule. For example, grammar 14 is a quasi-simple grammar. In order to do a top-down parse for this grammar, we have to again find the selection set for each rule. So now let's use our understanding of selection set for simple grammar first. The selection set for rule 1 is the terminal after derivation arrow, so it is A. The selection set for rule 2 is B. For rule 3 is C. What about rule 4? It is not epsilon. Epsilon is not a terminal. To find the selection set for nullable rules, we need to find the follow set. What is a follow set? The follow set of non-terminal A is all terminals that can appear immediately to the right of A when we do derivations. And just like all derivations, we start with starting non-terminal. Then whatever terminals that appear next to A will belong in the follow set of A. Additionally, if A is the end of the string or the rightmost symbol in a derivation, end marker is also considered as part of follow A. And finally, epsilon is never in a follow set. Let's look at how to derive follow A. Just like all other derivations, we need to start with a starting non-terminal. So I'm going to start with S and applying the first rule. S, end marker, can be derived to S, end marker. We are trying to find follow A. So in this derivation, this is our non-terminal A. Now let's look at the right side of A. The right side of A is S. S is a non-terminal and it is not a terminal. All the elements of the follow set of A must be terminals. Therefore, we need to do another derivation where we replace S with something else. Next, I'm going to replace S with rule 1 again. So it's going to be S, end marker. In this derivation, this is our A. Now, let's take a look at the symbol right next to non-terminal A. Lowercase a is a terminal. Therefore, lowercase a belongs in the follow set of A. So I'm going to include A over here. And then, right next to A is non-terminal S. So non-terminal does not belong in follow set. So this was replacing S with rule 1. But what if I replace this S with rule 2? So I'm going to get A, B, end marker. And in this particular derivation, this is our A, and right next to A is a terminal. And this terminal is lowercase b. Because B is a terminal, B also belongs in the follow set of A. What we need to do next is to try to replace all non-terminals to get what are the terminals that can appear right next to A. But actually, this is the end of all possible derivations that we can do where a terminal can appear right next to A. Therefore, the follow set of A is only A and also B. Now, for practice purposes, let's derive follow S. So for follow S, we begins with starting non-terminal S. So, because S is our starting non-terminal and S is the leftmost symbol here, and marker also belongs as part of the follow set of S. So we can include and marker as the first element. Okay, now I'm going to apply rule 1. So A, S, and marker. So this is our non-terminal, and right next to it is an end marker, but we already have end marker inside our follow S. Now, I'm going to continue the derivation by replacing this A with the third rule. So it's going to be A, C, A, S, S, and marker. Okay, in this derivation, this is our non-terminal, and right next to it is another non-terminal. Therefore, S cannot be included in the follow set of S. But what I'm going to do next is I'm going to replace this S with rule 1. So I'm going to get ACAS, AAS. So this is rule 1 from here. And in this derivation, this is our non-terminal S, and right next to S is a terminal A. So A belongs in the follow set of S. And what if here I replaced with rule 2, or I derive this S to rule 2, and I will get ACAS B. Okay, not forget the end marker at the end. In this particular derivation, this is our non-terminal S, and right next to S is a terminal B, which means B also belongs in the follow set of S. And that is the end of all possible terminals that can appear right next to non-terminal S. So we have managed to discover the follow set of A and the follow set of S. The selection set for a nullable rule is simply the follow set of the non-terminal on the left side of the arrow. So now, let's compute the selection sets for grammar 14. Selection set for rule 1 is A, rule 2 is B, rule 3 is C, and rule 4 is follow A, because A is the non-terminal on the left-hand side of the arrow for rule 4. So follow A is this one here, which we have derived previously, which means the selection set for rule 4 is A and also B. Selection sets guide us which rule to apply when doing derivations. Let's demonstrate by drawing the derivation tree for the input ACBB. So this is our input and we want to draw the derivation tree for this input. I'm going to start, as always, with the starting non-terminal. So this is the current input, and the current input is A. There are two rules derived from non-terminal S, rule 1 and 2. Because we want to draw A, we choose the rule that has A in the selection set, and that is rule 1. So I'm going to apply rule 1 over here. A, S. So we are done with A. Now we move to C. And we want to draw C under the non-terminal A. So there are two rules derived from non-terminal A, rule 3 and rule 4. Because we want to draw C, we choose the rule that has C as its selection set. And that rule is rule 3. So I will be applying rule 3 over here. So A is derived to C, A, S. Okay, I am done with C. Now I want to move to B, and I need to draw B under A. Again, there are two rules derived from non-terminal A, rule 3 and rule 4. And the rule that has B as its selection set is actually rule number 4. So I will be applying rule 4 here, epsilon. So if you look at the tree, we still haven't write B yet. So we still need to write B, but now we are moving up to this S. We are still trying to write B. Now we are looking at rules that are derived from non-terminal S, and they are rule 1 and rule 2. So from these two rules, we need to choose the one that has B as its selection set, and that rule is rule 2. So I will apply rule 2 over here and derive it to B. And this is done. Moving on, the next input is B, and I'm going to replicate the same thing. So this is how you draw a derivation tree for a particular input by using the selection set. So this is our derivation tree for A, C, B, B. The steps to construct an extended pushdown machine for quasi-simple grammar is actually similar to simple grammar. The difference is only here at step 4. And this is where we address nullable rules, which are rules derived to epsilon. For example, A can be derived to epsilon. Instead of writing replace epsilon retain, instead we write pop retain. So this is wrong, and this is the correct way of addressing nullable rule when constructing an extended pushdown machine for quasi-simple grammar. Now, let's construct an extended pushdown machine for grammar 14. So this is grammar 14 and the selection sets. First, I'm going to count the number of symbols in grammar 4. So we have 2 non-terminals, and we have 3 terminal symbols, and then at the end we're going to need 1 bottom marker. So it means we need to have 6 rows. As for the column parts, because we have 3 terminal symbols and we need to have 1 end marker, so we need to have 4 columns. So I'm going to draw the frame for our extended pushdown machine, starting with the rows. So we need 6 rows. So first the header, and then 1, 2, 3, 4, 5, and 6. Okay. Next, we're going to need 4 columns. So 1, 2, 3, 4. Okay, I apologize for how not straight my lines are, but you get the content is what matters, right? Okay, and then I'm going to fill up the rows part with all symbols. So we're going to start with the starting non-terminal S, and then non-terminal A, followed by all the symbols A, B, C, and bottom marker. As for the column part, all terminal symbols only, A, B, C, followed by end marker. Okay, now we need to fill up the cells in our extended pushdown machine for grammar 14, and I'm going to start with rule 1. So for rule 1, the selection set is A. So for the place of non-terminal S that meets A, I'm going to fill it up with replaced S A retain. Okay, I'm done with rule 1. Now for rule 2, the selection set is B. So for this cell, replace B retain. Okay, this is done. For rule 3, the selection set is C. So for A intersect with C, it's going to be replaced as AC retain. Done. And for rule 4, the selection sets are A and B. So for A that intersect with A and also B, instead of writing replace epsilon retain, we fill it up with pop retain. Okay, as for the rest, it is the same with simple grammar. For the terminals that meet with itself, it is pop advance. Okay, for bottom marker meeting end marker is going to be accept. As for the rest, it's going to be reject. So this is the extended pushdown machine for quasi-simple grammar, grammar 14. Okay, now let's use the extended pushdown machine that we have constructed and do a stack parsing for the input string A, C, B, B. And as usual, we need to initialize our stack with bottom marker and our starting non-terminal. So our starting non-terminal is S. So I'm going to start with the first input, and the first input is A. Okay. As with A, it says replace SAA retain. And in order to do that, we will take out the symbol on top of the stack, we remove it, and we replace with the symbols inside the parentheses. So it's going to be SAA. Retain. Retain means we are still in the current input pointer. Okay, moving on. We read A. The symbol on top of our stack now is A, and the current input is also A. So A with A, it says pop advance. So pop advance means we need to pop symbol on top of the stack, and that symbol is A. Then we advance to the next pointer, and that pointer is C. Okay, next we read A and C. A and C is this here, and it says replace SAC retain. So we take out the symbol on top of the stack, and that symbol is capital A, and we replace it with SAC, and we retain the current input pointer. Moving on, we read C and C. So C and C is pop advanced. So let's do another operation of pop advance. We pop C out of the stack and we advance to the next input pointer, which is B. The next stack will be A meeting with B, and it says pop retain. So I'm going to demonstrate how are we going to do this. So pop retain means the symbol on top of the stack is popped out, so we are left with SS, but in contrast with pop advance, we do not move to the next pointer. We are retaining the same input pointer of this B. So we do not move to the next input pointer. Okay, next we read S and B. So S and B, it says replace S retain. So we take out the first S and we replace it with B and we retain. Next we read B and B. So B and B is pop advance. So we take out B and we move to the next pointer, which is the second B. And then S and B again is this one. So we need to replace the symbol on top of the stack with B. So we take out S and we replace it with B. And then we retain the current input pointer. And then we read B and B. So B and B is pop advance. So pop advance means we take out B and then we advance to the next pointer, and since we have reached the end of the input string, the next input is end marker. I'm going to use red pen. Okay, end marker. And then we read bottom marker and end marker. It says accept, and we write accept here, which means the input ACBB is accepted by the extended pushdown machine for grammar 14. And then another way of parsing an input symbol that we know of is through a recursive descent parser, which is a set of methods written in a programming language such as Java or C++. We have discussed this method before in simple grammar. For quasi-simple grammar, the concept is still similar. The difference is only for nullable rule, where instead of reading the next input, we just proceed without reading any input. We just return to the calling method. Here are the two methods, S and A for grammar 14. Method S is for rule 1 and rule 2, and these two are from the same non-terminal S. Meanwhile, method A is for rule 3 and rule 4, and they are both for the same non-terminal A. Here we are more concerned with rule 4 because this is the nullable rule. And previously we have discovered that the selection set for rule 4 are A and B. So the codings in pink here, this is showing how to write the lines for a nullable rule in a recursive descent parser. So this is for rule 4. Else if input equals to A or input equals to B, and this is corresponding to the selection set of rule 4, and this is what we do. We do nothing. In contrast to rule 3 over here, we handle terminal by calling the next input. But since rule 4 is a nullable rule, we do nothing and we signify that just by leaving a semicolon. And that's it for the recursive descent parser for quasi-simple grammar.